Okay. Composite shaft consists of copper rod of 30 mm diameter enclosed in a steel tube of external diameter 40 mm and 5 mm thick. To stop. The shaft is required to transmit a torque of 0.5 kN meter. To stop. Determine the shearing stresses developed in the copper and steel. If both the shafts have equal lengths and welded to the plate at each end so that the twists are equal. So take CC, modulus of rigidity of copper it is 40 GPa and modulus of elasticity for steel it is 80 GPa. First of all, write down the given data. So diameter of copper rod it is given DC is equal to, it is denoted by DC, it is 30 mm. Okay. So external diameter of steel tube it is TS is equal to 40 mm. 40 mm and thickness it is given T is equal to 5 mm. T is equal to 5 mm. T is equal to 5 mm. Okay. Then calculate the internal diameter of steel. Small ds is equal to capital DS minus 2 into T. 2T. 2T. Okay. So external diameter it is 40 mm. 40 minus 2 into 5. 2 into 5. So that will be 30 mm. Internal diameter of steel it is 30 mm. Okay. 30 mm. So torque, the shaft is required to transmit a torque it is 0.5 kN. Means total torque shared by copper plus torque shared by steel it is 0.5 kN meter. 0.5 kilonewton meter. Okay. That is convert it is in mm. TS plus TC plus TS is equal to 0.5 into 10 raised to the power 6 Newton mm. Newton mm. Okay. Newton mm. Then modulus of rigidity for copper it is given, that is CC is equal to 40 GPa. 40 GPa. Okay. 40 GPa. That is converted is in mm. 40 into 10 raised to the power 6 Newton per mm square. Newton per mm square. Okay. Newton per mm square. Then modulus of rigidity for steel it is also given, that is denoted by CS is equal to it is 80 GPa. 80 GPa. That is converted is in Newton mm. So 80 into 10 raised to power 6. Sorry, 80 into 10 raised to power 3. 10 raised to power 3 Newton per mm square. Newton per mm square. Okay. Newton per mm square. So it will be converted is in Newton. So this one it is also 3. Sorry, this one it is also 40 into 10 raised to power 3 Newton per mm square. So this one it is in GPa to Newton per mm square. That is MPa. We can say it is also MPa. Okay. So first of all, calculate polar moment of inertia for copper. Polar moment of inertia. Polar moment of inertia for copper. For copper. For copper. That is IP is equal to pi d raised to 4 divided by 32. Pi into diameter of copper it is denoted by DC. DC raised to 4 divided by 32. Diameter of copper divided by 32. Okay. This one it is polar moment of inertia for copper. Okay. So diameter of copper it is given, that is 30 mm. Pi into 30 raised to 4. Pi into 30 raised to 4 divided by 32. Divided by 32. Divided by 32. So is equal to, so pi into 30 raised to 4 divided by 32. So this one it will be at 79.52. 79.52 into 10 raised to the power 3 mm raised to 4. Mm raised to 4. So this one it is polar moment of inertia for copper. It is solid. Okay. So 79.5 into 10 raised to power 3. I will note down this value. Okay, 79.52 into 10 to the power. The next polar moment of inertia for inertia for steel. So steel it is hollow tube. Okay. So IP is equal to, for that IP is equal to pi into in bracket capital DS raised to 4 external diameter of steel minus small ds raised to 4, that is internal diameter of steel, divided by 32 divided by 32 divided by 32 divided by 32 okay, divided by 32. So is equal to cap pi, it is pi in bracket external diameter of steel it is given, that is 40 raised to 4 minus 30 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 raised to 4 divided by 32 divided by 32 divided by 30. It will be get polar moment of inertia for steel. Okay, IP is equal to so pi into 40 raised to 4 40 raised to 4 minus 30 raised to 4 divided by 32. 171.805 into 10 raised to the power 10 raised to the power 10 raised to the power 3 10 raised to the power 3 mm raised to 4 mm raised to 4 okay, mm raised. So I will note down this value. So this one it is 171.805 into 10 raised to the power 6 mm raised to 4. Okay. So now next calculate torsion equation. Write down torsion equation in terms of angle. Okay, angle of twist. Torsion equation in terms of angle of twist. WIST twist, that is bracket theta. Okay, so we know that T divided by IP. T it is torque divided by IP, it is polar moment of inertia. IP is equal to C modulus of rigidity into theta, C theta divided by L. L it is length of shaft. Okay. So now theta is equal to T into L divided by IP into C. Okay. So for copper now, theta C is equal to TC into LC. Theta C is equal to, so this value to be get in radians. Okay, can write down it is in radians. Okay, so TC into LC, length of copper is equal to length of steel because of composite. So IP into CC, polar movement of inertia for copper into CC, modulus of rigidity of copper. Put all this value here. Theta C is equal to TC into LC divided by so polar moment of inertia for copper we are calculated. So this one it is 79.52 into 10 raised to the power 3 into modulus of rigidity of copper, it is 40 into 10 raised to the power 3. So calculate TC is equal to LC is equal to, write down final equation. Just simplify this equation. TC into LC divided by 79.52 into 10 raised to the power 3 into 40 into 10 raised to the power 3. It will be 79.52 into 10 raised to the power 3 into 40 into 10 raised to the power 3. That will be 7.808. Sorry, 3.1808 into 10 raised to the power 9. 10 raised to the power 9. Okay. So similarly calculate polar moment of angle of twist for, that is theta S is equal to TS into LS divided by IP into CS. Okay. So right, put all this value. TS into LS divided by so polar moment of inertia for steel we are calculated, it is how much, this one it is 171.805 into 10 raised to the power 3 into, so CS it is 80 into 10 raised to the power 3. Okay. So final value it will be get theta S is equal to right, theta S is equal to, I will write down below this one. Theta S is equal to TS into LS, it is TS into LS divided by 171.805 into 10 raised to the power 3 into 80 into 10 raised to the power 3. So this one it is 1.3744 into 10 raised to the power 10. Okay. So this one. Okay. So in this equation it is given that the shaft is, determine the shearing development if the both shafts have equal length and welded plate each other, so that their twist will are equal because of composite. So theta C is equal to theta S. So equate this equation. So equate these two equations. Because of composite, so angle of twist will be same. Okay. Equate these two equations. That is means theta C is equal to, theta C is equal to theta S. Okay. So theta C it will be TC into LC divided by 3.1808 into 10 raised to the power 9 is equal to is equal to TS into LS into TS into LS divided by 1.3 1.3744 into 10 raised to the power 10 raised to the power 10. Okay. So because of same length, composite it will be, because of composite LS is equal to LC, so that's why it will be get cancelled. So TS is equal to 1.344 1.3744 into 10 raised to the power 10 raised to the power 10 divided by 3.1808 into 10 raised to the power 9 raised to the power 9 into TC. In terms of TC is equal to TC, it will be get one equation here. So 1.3744 into 10 raised to the power 10 divided by 3.1808 into 10 raised to the power 9. So it will get 4.32 into TC. Okay. So put this in equation number 1. Put this one in equation number 1. This one it is equation number 2. Okay. So we know that TS plus TC is equal to TC plus TS is equal to 0.5 into 10 raised to the power, can write down only 0.5 kilonewton meter. It will be kilonewton meter. Okay. Put here this value. So we know that TS is equal, so TC plus TS is equal to 4.32 TC is equal to 0.5. So TC is equal to, write down TC is equal to 0.5 divided by 1 plus 4.32. 1 plus 4. That will be 0.093. 0.09398 kilonewton meter. That is converted in Newton mm into 0.09398 into 10 raised to the power 6. 10 raised to the power 6. It will be get in Newton mm. TC is equal to into 10 raised to the power 6. It will be get 93.984 into 10 raised to the power 3. 10 raised to the power 3 Newton mm. Okay. So we know that TS is equal to 4.32 TC. 4.32 into TC. Okay. So we call this 4.32 into 93.984 into 10 raised to the power 3. Okay. So TS is equal to 4.32 into 93.984 into 10 raised to the power 3. It will get 406.015 into 10 raised to the power 3 Newton mm. Okay. Newton mm. So this is torque developed in steel and copper. Okay. So now calculate shear stress induced in. So now shear stress induced in copper. shear stress induced in copper. So we know that T is equal to 5 by 16, 5 by 16, 5 by 16, 5 by 16 into D cube into Fs into Fs. So T it is copper, it is 93.984 into 10 raised to the power 3 is equal to 5 into 5 into 16, 5 divided by 16, 5 divided by 16, 5 divided by 16 into D cube, it is diameter of copper, it is 30 cube into Fs. So shear stress induced in copper, it will be get from this Fs. Okay. So write down Fs is equal to, from this Fs is equal to 93.984 into 10 raised to the power 3 divided by 5 by 16 into 30 cube raised to 3. So it will be get 17.7 to 17.728 MPa. So shear stress induced in, sorry, this one it is copper. Shear stress induced in copper. Okay. So this one it is shear stress induced in copper. Shear stress induced in copper. So now shear stress induced in steel. Calculate shear stress induced in steel. Shear stress induced in steel. That is Ts is equal to 5 by 16. 5 by 16. 5 by 16. 5 by 16 into Fs into, in bracket, capital D raised to 4, capital D raised to 4 minus small d raised to 4, minus small d raised to 4, small d raised to 4 divided by capital D, divided by capital D, divided by capital D, capital D. Okay. From this equation it will be get, so Ts it will be 406.015 into 10 raised to the power 3 is equal to 5 by 16, 5 by 16, 5 by 16, 5 by 16 into Fs into capital D raised to 4. So how much capital D raised to 4? It is 40 raised to 4, 40 raised to 4, 40 raised to 4 minus 30 raised to 4, minus 30 raised to 4. Okay. So now divided by 30 raised to 4 divided by, it is capital D, it is 40. 40. Okay. It will be get from this value. So Fs for steel it is, first of all, calculate this one. 40 raised to 4. 40 raised to 4 minus 30 raised to 4 divided by 40 into 5 by 60. 5 by 16. 406.015 into 10 raised to the power 3 divided by answer. It will get 47.26. I will cross check this value. 47.26, correct. So Fs is equal to shear stress in steel is equal to 47.26. 47.26 MPa. So this one it is shear stress in steel. Shear stress in steel. Okay. In steel. Or shear stress in steel. So shear stress induced in copper it is 17.725 MPa and shear stress induced in steel it is 47.26. So this one it is shear stresses and torsion induced in the given composite shaft. Okay.